So in the last few slides, we've looked at the growth of an amoeba. And what you've seen is we've been working with this equation here, G equals 1500T plus 45. There's a couple of things I'd like to review with you, okay? One is when you got to the slide, you'll notice that when you graphed it, you only see one quadrant, okay? So we talked earlier about how there was 4 quadrants, right? But these other quadrants, so this would be quadrant 1, 2, 3, and 4, but we're only using quadrant 1. And why we're only using quadrant 1 is because it's the one that has positive x values and positive y values, okay? And we're not going to call them x and y, but this is where we went before, okay? The other ones all had negatives attached to them. And if we're dealing with a practical and application question where we're dealing with time and we're dealing with length, or G for growth, right? You can't have negative time. We're not going to get into the time warping continuum. The reality is you cannot have negative time, and your length won't be negative either. So an amoeba it'll grow, it'll get longer, right? So we're only using the positives and the positives. We're only using that first quadrant, and that's common in application questions. Okay? The second thing I'd like to talk about is this is the same, we'll get a different color here, as if I said y equals mx plus b, right? So 45 is our starting point. That's going to go on the y or independent variable axis, okay? Instead of an x, we have t, and instead of a y, we have g, right? But we end up, if you look through the slides, with the same table of values. We're just comparing, instead of comparing x to y, we're comparing the time to the length. And you're saying, why didn't I use L for length? Well, we could have, because you can use any letter, but we use G for growth, even though we're looking at the length, okay? So instead of x and y, we just use the variables t and g, right? And what that means is instead of x, this is time, and this is growth. Time and growth, right? Now we introduced a couple of words where we called this time the independent variable, which means the x is the independent, which is now the t. And the vertical axis has the dependent variable, right? And what that means is time, we get to pick it. So you would always say the growth of an amoeba is dependent on the time. Let's look at your own growth, right? Your own growth as a human being. We could say at age 2, you were whatever, a 1 meter, right? And then at age 3, you were taller. And at age 4, you were taller. So your growth depended on the time, okay? You can't say your time depends on your growth because time passes. But your growth, some of you grew faster than others. So that's why growth is the dependent variable, because it depends on the passage of time. Same thing for the length of the amoeba. The length of the amoeba will get larger, but it will be dependent on the passage of time. Passage of time is independent because it happens all the time. You can't stop it, it just continues and continues. So what you're looking at on the group of slides is that this one was 0 and 45. And then I believe the next one we used time of 2. And then we put in a 2, 1500 times 2 is 3000, and 3045, okay? Now I'm not going to graph this because you have this table of values and you have the graph in the slide, but it's understanding what it means. And what you will see, I'll just take out some red here, what you will see is starts here, starts small, and you'll notice the graph grows, right? The graph grows. Over time, the amoeba gets longer. So that's the basic concepts around it. You have an equation, different variables, but it's still like y equals mx plus b. We would still create a table of values, and then we would still put those points on wherever you put them, okay? And then you can show that it grows, right? And you can work with the slope in that as well, okay? Hope that makes sense. If not, make sure you message me and get a hold of me, or we'll talk about it in the tutorial as well. See you next slide.